In this video, I'm going to be talking about Notes 2.1, Quadratic Functions. We have two basic forms that you guys are going to see quadratics in. We have general form, and we also have standard form. Notice the difference between the two. General form is the way you've been used to seeing it before, where it's ax squared plus bx plus c, right? We can use our quadratic formula if you want to find the zeros or all that fun stuff. In order to find the vertex, don't forget the vertex of a parabola is just where it changes directions. So if I have a parabola, say like that, then the vertex is just going to be where it changes directions. Well, going up, 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 and then once it hits this point about right here, it changes directions and it's going down. The axis of symmetry is just the imaginary line over which it reflects. So in this case, it's the exact same as the vertex, and it's actually always going to be the exact same as vertex because the vertex is where it changes directions, or where it kind of just repeats itself over again but in the other direction, where it is symmetrical to itself. Okay, standard form, much easier to find the vertex. Okay, we can just pull it out as hk. Don't forget you have a negative h here, so you need to pull it out as a positive h. When it's inside with the x, do the opposite, so that's why it's going to be a positive h, or whatever the sign is, just change it. For your axis symmetry of this and the other one, it's just x equals whatever number you find your x value of your vertex to be. One type of problem that you're going to see is converting a general form to a standard form. The way that we do this is exactly just completing the square if we can't factor. So since this doesn't make a perfect square itself, I'm just going to complete the square. If you don't remember how to complete the square, you want to refresh on it, look at my other video, Completing the Square Review. That'll help you out tremendously. So first thing, I'm going to change f of x to y just to make it easier, and I'm going to move over my 7. So I have y minus 7 equals 2x squared plus 8x. Now when completing the square, don't forget that our term in front of our x squared needs to be 1. So in order to make this 2 into a 1, I need to factor out 2 from both of these terms. So then I will have y minus 7 still equals, factor out the 2 times x squared plus 4x. Now we can actually do the completing the square part. So I have y minus 7 plus some number, I don't know what it is, equals 2 times x squared plus 4x plus some number, I don't know what that is. However, what goes in here is negative b over 2a squared. Again, if you don't remember this stuff, you can look at the complete square review. I go over it in much more depth in that video. So into this blank I have negative b over 2a squared. Or sorry, negative b over 2 squared rather. Not a, no a there. Come on. Erase it, erase it, erase it. Ah, no a, negative b over 2 squared. Okay, so if I'm in that blank, negative b over 2 squared, b is 4. And really it's just positive b over 2 squared. My bad, I'm sorry. Okay, b over 2 squared. So b is 4 divided by 2, which is 2, square 2, so I'm going to add 4. Now notice on this entire side, I really added 2 times 4, so on this side I need to add 8. So after all of that, I have y plus 1. Now this will factor, this is a perfect square, into 2 times x plus 2 squared. Subtract your 1, change the y back into f of x, and you have f of x equals 2 times x plus 2 squared minus 1. Again, if that's a little bit hard for you still, go back, look through my complete square review video, and it'll make it much simpler. Another type of problem is you're going to have to give me the vertex, the axis of symmetry, and then you're going to have to graph it. Well, this is already in standard form, so it makes it really easy to pull out the vertex. Inside with the x, so I'm going to pull out the opposite. Outside with the y, so there's my vertex. Vertex is 6, 3. Cool. Axis of symmetry, I know it's just the x coordinate, so x equals 6. There's my axis of symmetry. Cool. All that's left is to graph this thing. So at 6, 3 I have my vertex, so over 1, 2, 3, 4, 5, 6, up 1, 2, 3. There is my vertex. Axis of symmetry is 6, so that's good. I know this is positive, so this is going to open up. And I don't even have any x-intercept since it's never going to cross the x-axis. So that's a pretty cool graph. Banana! Okay, and this one doing the same sort of thing, but this one's in general form. If you want to, you can convert it to standard form since this thing will factor out, which also makes it way, way, way simpler to find the zeros. So if I factor this is x plus 1 times x plus 1, which is the same thing as x plus 1 squared. So if my function is equal to x plus 1 squared, there's my vertex. I have negative 1, nothing on the outside, so 0. So my vertex is negative 1, 0. My axis of symmetry is the x part, so x equals negative 1. And my zeros, I know I'm going to have x equals negative 1 as my zeros as well. Okay, so when I graph, I'm going to hit negative 1. That's my only 0. I know it's positive. This is also my vertex, so it's going to open up. There's our graph. Beautiful. Another type of problem that you're going to see is the same sort of thing. We're in general form, but you are going to have something like this where you're going to have no calculator. So we're still going to have to give the vertex, the axis of symmetry, find the zeros, and graph it. Okay, seems a little bit daunting right now, but it's not so terrible. Because for the vertex, if you want to, since we're in general form, you can use your negative b over 2a and f of that. Don't freak out about the f of that part. F of negative b over 2a just means what's the y when x is negative b over 2a. So b is negative 4, so I have negative 4 over 2 times a is negative 1. So then I have positive 4 over negative 2, which is negative 2. So now I know the x part is negative 2, so I can go back into my equation and plug in negative 2 to find what is missing for the y part of my vertex. Well, when I do that, I have negative 2 squared minus 4 times negative 2 minus 3. This part is a positive 4, so I have negative 4. Negative 4 times 2 is plus 8 minus 3. So I have negative 4 plus 8 minus 3. Negative 4 and negative 3 make negative 7 plus 8 is 1. So my vertex is negative 2, 1. Okay, there then I also have my axis of symmetry is the x part, so x equals negative 2. If you want, well, now we have to find the zeros. Okay, to find the zeros, I can just factor this thing out. I'm going to erase this real quick. Don't forget, you can rewind and see it again if you want to. Use your video tools. Yay! So, in order to find zeros, usually we factor things. But in order to factor things, we want our leading coefficient to be 1. It just makes it way simpler. So if I factor out a negative from all of these terms, x squared plus 4x plus 3, then this is the same thing as negative x. And if I factor, I know that my terms multiply to be 3. And they add to be a positive 4. So they must both must be positive. The only two things that multiply to be 3 and add to be 4 are 3 and 1. I have something times something else equals 0. So then x equals negative 3 and x equals negative 1. There are my zeros. I know my vertex. Very simple to graph this thing now. Vertex negative 2, 1, so I can go over 2, up 1. There is my vertex. I have negative 3, so I have negative 3. There's 1, 0. Negative 1 is another. Looks like this parabola is going to have to open down. There it is. You're also going to see problems like this. Again, this is going to be something that you're going to have to do without a calculator. Write the standard form if the vertex is 2, 3, and we pass through the point 0, 4. Well, I know standard form looks something like this. F of x equals a times x minus h squared plus k. I have an h, I have the k. So really, so far I know f of x equals a times x minus 2 plus 3. Oh, don't forget your squared. And the only thing I don't know is the a. However, it gives me that it's supposed to go through this point. So I kind of have an x value, kind of have a y value. So I can just use those points to help me figure out what a is. So if y is 4, when x is 0, then I can solve for a. So then 0 minus 2 is negative 2. Negative 2 squared is 4. So it's like 4 equals 4a plus 3. Subtract 3 to the other side, divide by 4, so we know that a is 1/4. Well, there's the last part of my equation. So I can write my answer as f of x equals a is 1/4, 1/4 x minus 2 squared plus 3. Done. Ooh-na-na. Thank you guys for watching. Hopefully this helps out. And appreciate your time.